So I'm here on the beautiful island of La Palma. It's a Thursday afternoon, incredible day, with Susan Nehzati, if hope I got that right, who is a geochemist at the Lund University in Sweden, who has just presented a poster paper. I think it was yesterday or the day before, describing she and colleagues' work on spherules dating back from 66 million years ago, and the impact that caused the destruction of the dinosaurs. Can you explain?
Sure. So my colleagues and I, we are using various X-ray methods to chemically identify the mineral phases that are within these spherules. So these spherules are found globally, and with X-ray methods, we can identify what kind of chemicals we can find within them.
And what does the abundance of these chemicals in the spherules tell you?
Not only the abundance, but it's also the distribution within them and the types of nucleation or crystallization patterns that we see within them. So it could tell us how they were formed and why they were formed in the way they are. So sometimes they're beautifully spherical, sometimes they're dumbbell shaped. They have all these different states that we can tell by what kind of chemical species that they might be.
So tell us a bit about where you actually found these in Denmark.
Sure. So this one site that we look at is at Stevens Klint. It's about an hour south of Copenhagen in Denmark, and it is a very beautifully exposed cliff of the sedimentary boundary that shows the KT boundary layer. And so it's a World UNESCO Heritage Site, and I definitely highly recommend everyone to visit it if they can.
And you told me that that Alvarez obviously was one of the first people to kind of provide proof of this impact theory because of iridium. But your work in the analysis of these spherules is further evidence that correlates this impact theory, is it not? Can you explain?
Sure. So it's in two ways. So one, it's because of where these spherules are placed. So it's really at that bed of that KT boundary that we see at Stevens Klint that we've collected these spherules from.
And the KT boundary is, in lay terms, is what?
Oh, it's the extinction event between the two different geological eras.
And sometimes known as a KP boundary,
Yeah,
correct?
so it's the Cretaceous Paleogene boundary, some
Okay.
people like to call it.
But it is 66 million years ago. There's no doubt about that now.
Give or take 500,000 years, yes.
Okay.
Yeah.
So go ahead.
I forgot your question.
So about how there are two things.
Oh, right, there are two ways that we can sort. So one is because of the placement that they are at, but also when we look at within the spherules. So many of these spherules are still pristine and they've kept their original chemical makeup. And so if within them we see certain chemicals that we expect to see from asteroid material, then we can again confirm that this was a global event from an asteroid impact that had hit.
So at the beginning of our conversation, you told me how these spherules actually form. I thought that was amazing. Give us a little bit about that before I let you go.
Sure. So my background's in chemistry, and I just find this very exciting in that it was such a massive mass that came from outer space, right? It was a big asteroid over 10 kilometers hitting Earth at a high impact. So it had really high intense pressure, high intense temperature, and this created like this new experiment with these minerals. And because of this heat, it created a vapor plume of the target rock from Earth and also the asteroid material, and it just dispersed all around the globe.
So look forward to hearing more on this in the future as you guys continue your research. Thanks so much, Susan, for taking time.
Thank you.